So now we will look at some ways to do the training with gradient descent. When we talk about gradient descent, we usually have two main approaches for making the learning. We have what we call the batch learning. So batch learning is what we saw so far in the presentation, where we are making one update over the complete training set. So we are making several updates, many iterations, but at each iteration, the update is based on the complete training set. So this is kind of straightforward for the development of equations. This leads us to relatively stable learning because we are making one update over the complete training set. So that's good in terms of having a good signal to estimate the gradient in one position. But one other approach will be the online learning approach. And that is different in the sense that we are evaluating the gradient. We are making correction of the weights based on one sample. So that means that for each sample, we are making an update. And for like a full iteration that we have with batch learning, we will make n weights correction where n is the size of the training set. So this second one is guided, in fact, not based on the training set, but based on each sample of that training set. So the error is computed on one sample. And this requires some tricks. The first one is to be sure that we are kind of shuffling, making permutation of the samples in the training set at each iteration to process them in some random orders, because the order at which we are presenting the samples influence the outcome. And if, for example, we are unlucky and we have many samples from one class at the beginning and many other samples at the end, or maybe they are sorted in some ways, then possibly the learning will work not that good, because we will kind of making many updates on one side, and then we will make more updates on the other side after that. But the thing is that online learning allows a faster convergence, and that is kind of really useful, especially when we are dealing with neural networks. So far, the linear models are relatively simple. They are converging in a matter of few iterations with batch learning. So that may not be required for linear discriminants in general. But for more complex models based on gradient descent, online learning is kind of really useful because it allows to make updates faster. We will present just one sample before making an update. So we are starting to make many updates to the network over the iterations, and that is useful to converge faster. But it has the risk of greater instability. We can go even further away. We can go with what we call stochastic gradient descent, where we will just kind of pick randomly one sample from the training set and update our model accordingly. So a typical algorithm will be to say, yeah, let's pick one observation, and then what we do specifically with stochastic gradient descent, the nice trick is that we should in fact adjust the learning rate, and the learning rate starts higher, and over the iteration it goes smaller and smaller. It means that the first samples has a bigger influence, and that's fine because our model is probably not really good, so we can make good updates, but as we are going further along the updates, we will reduce the impact of these updates to something smaller to make finer tuning of the algorithms. And we are kind of applying these updates iteratively until we are converging, or we are over the number of iterations we allow us to do. So decreasing the learning rate is important for each data. This is a way to guarantee it will converge. And that stochastic gradient descent is super interesting when we need to deal with really huge data sets. When we have millions, dozens of millions of samples, we may not even need to go over all the samples to train our model. We may need to go over only a subset of samples that we see each of them once, and that will be enough. So stochastic gradient descent is a way to do gradient descent per sample, sampled over the training set randomly, and possibly not even looking at all the samples, only picking up a subset of them. And that's also good, as it is what we call an anytime learning algorithm. So it means that at any time we can stop it, and it will have a model that is well, maybe not the best one, but the best we can get at that point. And then that online nature is really can be useful in some cases. And that's also usable for the processing data stream. So there are nice properties for stochastic gradient descent. But one thing I can say is that it's not useful for really small data sets. It's useful for big data sets where we don't want to go through all the samples, but for small data sets, making use of an online approach that we saw just the slide before makes sense in some cases. It depends on the models. Maybe with simple models, the batch approach is good enough, but for some others, online learning may be good, but stochastic gradient descent is kind of the extreme cases that is very useful for really big data sets.